I think I'm sharing correctly.
Yes, it's working.
Okay, perfect. So hi everyone. I'm Cami from University of Notre Dame. I just wanted to talk a little bit about integrating Coffee, which we just heard a little bit about, and Work Queue. So just a little bit about Coffee, since we talked about that a lot previously. It's just a prototype package for pulling together some experimental analysis for high energy collider physics using Python. I put a link in my notebook to its webpage if you want to check that out. So,
Cami, quick request. Can you zoom your browser so that it fills, so that the content fills the screen? So just zoom like Control Shift plus. That's right.
Is that okay?
A lot easier to see. Yeah.
Okay. So just continuing. So what is Work Queue specifically? Work Queue is a framework for building large applications that you can basically run on thousands of machines drawn from different clusters and clouds and grids and such. And I put a link in my notebook as well for that, for Work Queue. So why is Work Queue interesting at all? It's elastic, so workers can be added and removed during runtime, and the master automatically uses whatever workers are available. It's robust, so tasks running on workers that fail are automatically detected and handled elsewhere. It's efficient, so files can be cached at the workers, which reduces transfer times and improves network utilization. There's resource management, so worker resources such as cores, memory, and disk are automatically measured, so we can run as many tasks as possible given whatever workers we have available to us. And lastly, it's agnostic. So masters can be written in Python, Perl, or C as of right now, and it's able to work with a few existing cluster and cloud systems such as HEC Condor, PBS, Torque, Slurm, and EC2. So in order to actually run Coffee and Work Queue, we need to set up a Conda environment. So I've already done this, so I'm not going to do this right now because it takes a few minutes to actually install and pack everything. Just a quick note on distributed systems. I don't know how familiar everyone is with it. So whenever we want to run a task on a remote worker, we have to send all the files and all the programs that a task is going to be using. So we have to pack our Conda environment into a file that we're going to send to workers that the workers then will unpack and use to be able to run tasks within the environments. So just some importing statements here. We have Coffee, NumPy, awkward, time. Then we get into our processor, which can be found at this link that I have attached here. And you can look through that and kind of see what it does. So the first thing we have to do is set some variables that we need. First is chunk size. It tells us how many entries from the file we're going to process in a single task. And obviously a larger chunk size allows for less tasks and larger tasks. So the chunk size that we're using is going to result in 50 tasks for us. The next thing that we set is the file set, which is a public file actually, and it's located here at this, or it can be found here at this link from the Coffee team website. So the last thing we do is set some executor arguments. Most of them are unique to the Work Queue executor, but some of them are used for most of the other executors, like flattening, compression. So for cores, memory, and disk, we have to tell the Work Queue master how much of each resource a task is going to be used. It's not entirely necessary, but it improves performance by a lot when we're using accurate values. And I guess the first question that comes up is, how do we get those accurate values? Well, we have this tool from Notre Dame called the Resource Monitor, which monitors the computational resources used by these different tasks and all of its descendants and everything. So use the Resource Monitor, and it tells you how many cores and disks and memory to set up, essentially, or yeah, how many resources a task is using, and then you can use that for future tasks that you will be running that are similar in size and such. The port is just the port on which the master is going to listen for tasks on. 0 just specifies any available port. The environment file is the tarred conda environment that we had packed at the beginning. And it's going to be sent to each worker so that we can run Coffee on it. And the master name is just necessary to be able to run work queue. The workers use the master name to connect to a specific master based on its name. So let's just run that real quick. So I wanted to run Coffee using the iterative executor before diving into work queue. I'm going to start that because it's going to take a little while. So kind of what we had seen previously is just going to split the data set that we have into various tasks and just run them sequentially. It does the processing via the fancy Daemon processor. It has this same method that we had seen earlier, the run uproot job. So we'll just wait for that to finish so we can have some comparison between the two later on. And while that's going, I can sort of talk about for Coffee and Work Queue, we need to request some workers. So you can start a work queue worker on your local machine with the work queue worker -m work queue Coffee, or whatever your master name ended up being. This has to be within the same machine and obviously the same environment as the rest of the notebook is running in. And then we have some similar commands for to start multiple workers on other batch systems. So Condor, SGE, PBS, Torque, Slurm, EC2, they all look essentially the same except for the prefix on there. So here we're specifying the master name as well as cores, memory, and disk. These numbers are different than the task numbers that we had specified previously because these are how big we want the workers to be. So these have to be strictly greater than the size of the task so that task can fit on workers. So you could just picture it as two boxes fitting one inside the other one. I'm going to start this because it's going to take a little while to run actually. So I just put a link there for some further information about actually being able to run work queue. It's super helpful running a work queue application on our documents. So any second now, we're going to see that we have some tasks submitted to our worker, to our work queue. And essentially what happens now is all 50 tasks are submitted at once is what it seems like. And then the work queue master waits on tasks to start completing after it sends them to different workers. So this processing is just to actually split up the different tasks and then it'll actually start submitting them now. So a quick note on like the conda environment part. So each worker that's running tasks, we have to actually take that tarred file, untar it, unpack it, and set up the conda environment so that we can actually run the tasks from within that environment. And from our measurements, the setup process can take anywhere from a few seconds, 10 seconds to a few minutes to run. depending on the machine, how many users are using it, and just its what resources it has available. And only once that has completed can we actually start to run the tasks. So each task right now checks whether the environment is already set up. And so that adds an extra few seconds of runtime, even if the environment has already been set up. That's about 2 to 10 seconds as opposed to 10 seconds to a few minutes. So unfortunately, we do have to deal with that kind of overhead. So we can see now that some tasks have been submitted. We have 50 tasks that have been submitted so far. And so this is the command that is going to be run on the remote worker. The Python package run is just a script that envelops the untarring and unpacking of the environment along with the actual running of coffee. So that should be, yeah. So we can see some tasks have started to complete already. So here we have the same command as we saw before and some output. So this output is from the resource monitor right here. This gives us the measured cores, measured memory, and measured disk that the task was actually using. So we can see that the cores we allocated was good. Our memory was a little bit greater than we needed, but still good enough to run it. And then disk was the same. So our runtime ended up being about 36 seconds, 39 seconds, and then we dropped down to 7 seconds to when the environment has already been set up. So immediately we can see that there is a significant overhead just for having to start up these environments. But we only have to do those once on each worker. And so it's very useful to be able to run multiple tasks concurrently. So this should be finishing up soon. Oh, it finished. Okay, perfect. So just gonna clean up and then some comparison just to see the different times. So for the iterative executor, it took about 100 seconds. For the work queue executor, it took about 250. So there was a little bit of a slowdown, unfortunately, where we're kind of looking for that 10 times speed up with the 10 separate workers. So both of these are still, or the combination of Coffea and Work Queue is still relatively new. It has a long way to go still. So this is just kind of, it works for now and the performance isn't terrible, but we're still working on it and trying to get it up there so that it's efficient and usable and we can go forth and actually use this and speed up all our processing and analysis and such. And I think that's all I had. I guess if anybody has any questions.
Yeah, well, thanks very much for going through all that. Yeah, so we definitely do have some questions in Slido. So I'm gonna once again just drop this into the chat window. The existential parallel progress bars. Yes, indeed, Lindsay. Right, so if you can open up the Zoom chat and then go to the link that's there, then we can step through the, we have 4 questions from the audience.
Okay.
Yeah, great. Okay, so let's start with Peter. So in which situations would work queue be a better solution and in which ones would Dask be preferred?
Honestly, I think I don't know too much about Dask, so I can only speak for work queue. So I think it just depends on what resources you have access to and whether or not you need to use like a shared resources and such. So I don't know if that entirely answers your question, but I can get back to you offline maybe later.
Sure. Peter, since you're connected, do you want to add any additional follow-up or questions, or is that good?
No, that's good. We can talk about it a little offline.
Okay. Okay, right. So now next. Yeah, so Conda M's can definitely get to be pretty big. So what's your overhead in terms of actually distributing them to the workers?
Yeah, so like I mentioned, that overhead is anywhere from like in terms of time, it's anywhere from 10 seconds to a few minutes, depending on what machines the workers are running on. In terms of data being sent, it for 30 workers, so sending the content environment 30 times essentially is about 7 gigabytes. The content environment that we're using essentially. So I hope that answers the question.
Yeah, I think it seems so. Okay, and then we have another Conda related question. How does the environment work in a multi-user environment? Does it get cached on the workers? And if so, how are you setting the expiration?
So it doesn't get cached on the workers. It gets cached, let me rephrase. It gets cached for the lifetime of the application, but once your 50 tasks are done, then the workers essentially forget about everything that they've received, any files essentially. So you'd have to resend that on a subsequent run.
Okay. We got 2 more. We have one from Ben, and I guess this goes out to the coffee team in general. So you're exploring many different executors, as we saw. So is this to be able to try and work across many sites to see what's out there, or to build the most versatile tooling possible? And like long term, do you expect to focus in on just 1 or 2 once you've kind of done some exploratory analysis, or do you expect to kind of support all for the long term?
I can offer to reply if you like.
I can offer replies too, but Nick, go first.
Yeah, I mean, I think what is said is accurate. We do want to try what's out there. I will mention that the CC Tools group came along and submitted entirely, you know, on their own a work queue executor for coffee, and we worked with them to integrate it, and they did a really good job. And for sites that have access to the work queue executor, it's a perfect fit for them. Sites that don't may want to consider that or another option depending on what kind of resources they have. And as far as the core team's focus, traditionally we've been focusing on Spark and Dask, but we've certainly had work queue and Parcel sort of also in parallel, just to experiment and see if there's any any differences, any lessons that could be learned. Because each of these is in principle focusing on the same the same arena, the same problem. And it's very nice to see them all sort of on the same footing and see where the benefits and issues are. In terms of long-term support, though, I think that's up in the air.
Yeah, I mean, keeping the interface alive and making sure that Coffee works with a specific executor is something that's actually easy to distribute, where the work of the CC Tools team has shown that very clearly. The thing that I would add to what you said, Nick, is that a lot of these executors have wildly different capabilities beyond just the MapReduce parts of them, which is what we're using heavily, of course. and we're actually, learning what we want in a final system by having different executors with different capabilities. One that I always choose, of course, is Spark's ability to repartition data, to do outer joins of data between different data sets. So you can, for instance, do analysis debugging between two different groups very quickly. Similarly, another way you can take this is like Dask, I don't think has a very clean interface for dealing with multiple scheduler types, whereas both Parcel and Work Queue can tie together a Slurm cluster and a Condor cluster if you need to use both, or if you need to use a wider variety of resources. So there's lots of interesting different wrinkles to all the various executors that we're supporting right now, and I think it's helping us, or it's giving us a wider variety of experiences so that we can figure out the actual final system that we really want in the feature set that makes the most sense. And then, yeah, going back to the maintainability question, I think since it's starting to become the case that sites are starting to build, or sites are starting to build out infrastructure based on some of these schedulers, that there's going to be basically a federation of responsibility to people maintaining the executors that they need for what they want to run at their sites, kind of as Nick was hinting at. So I think it's actually a maintainable pattern to keep a very wide set of, or to keep a very versatile tooling, as you say, Ben. And at least in my mind, and of course this can change as we accumulate more experience, keeping that alive, or keeping that kind of spirit alive until we really know what we're doing, seems the best way to go for me in terms of steering the project.
Nice.
I'll say it does force you to be general in a way that if you were stuck in one tool, you might think you're general, but you're not.
Yeah, especially when we had to put Spark in there. That was a trip.
Yeah.
Well, thanks very much for that very nice and comprehensive answer. That's good. All right, and then one final question. So is the connection to the workers only something that's kept in memory? And so is it then lost if the Jupyter session stops?
I believe so. So I'm not entirely sure. I can actually check on that and get back to you if you want to send me a Slack message or something.
Sure. Yeah, if you could maybe just post that in the Slack and the normal chat, that'd be great, because then everyone would be able to see that follow up. Yeah. Okay, I think that's it for questions. So I guess unless anyone still has further questions who have been staying silent, I think that's it today.